You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Server Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Welcome to the Bare Metal Cyber Server Plus Prepcast. This series helps you prepare for the exam with focused explanations and practical context. Network cable redundancy is a cornerstone of modern server design. When servers lose network connectivity, even for a few seconds, it can interrupt user sessions, drop transactions, or break synchronization with other systems. In mission-critical environments, downtime is not an option. That is why redundant cabling is not considered optional. It is a core design element. Server Plus includes this topic within Domain 1 to ensure that candidates understand both the physical and logical aspects of keeping systems online at all times. Redundant cabling supports more than just uptime. It is an architectural strategy for system resilience. If one link fails, another takes over instantly. This can apply to cables, network interface cards, switches, or even rooms. Effective redundancy ensures that no single point of failure can sever connectivity. It requires careful planning of hardware, paths, and failover logic. Server Plus expects that candidates can both design and verify redundant network links as part of their infrastructure readiness. At the physical layer, redundancy often begins with dual network interface cards. Servers that require continuous access typically include at least 2 ports or cards, each connected to a different switch. These cards may be integrated on the motherboard or added as expansion cards. When configured correctly, the failure of one card or cable triggers automatic rerouting through the second. This is known as dual homing, and Server Plus includes it as a foundational principle of high availability design. Physical path separation is critical in this configuration. The 2 cables should not follow the same route through the rack. If they are bundled together, a single snag, fire, or cable tray failure can knock out both links. Instead, each cable should follow its own pathway, preferably using opposite sides of the rack or entering from different floor tiles. Physical separation provides fault isolation and supports continuous operation even during localized disasters. Switch diversity is another requirement. Connecting both redundant cables to the same switch creates a single point of failure. If that switch loses power, freezes, or is taken offline for maintenance, both links drop. Each cable should connect to a different physical switch, ideally powered by independent circuits and connected to separate upstream paths. This adds protection not only from hardware failure, but from firmware bugs, port exhaustion, or administrator error. NIC teaming and link aggregation are logical techniques used to combine redundant physical links into a single logical interface. In teaming, multiple ports are grouped to provide fault tolerance or load balancing. If one port fails, traffic continues through the others. Link aggregation, often implemented through LACP, the Link Aggregation Control Protocol, combines ports in a bonded channel that offers both performance and redundancy. Server Plus includes terminology and configuration awareness for these tools, which are essential in modern network design. Redundant systems operate in either passive or active modes. In passive redundancy, the backup link remains idle until the primary fails. This minimizes load on the secondary path but increases failover time slightly. In active redundancy, both links are live, and traffic is balanced between them. This improves performance and provides instant failover, but requires more complex configuration. Server Plus expects candidates to understand the difference and choose the correct model for each use case. Operating system configuration is an often overlooked part of network redundancy. Simply plugging in 2 cables is not enough. The system must be told how to handle failover, which interface is primary, which is secondary, and what criteria trigger a switchover. This may involve defining link health checks, MAC address policies, and bonding drivers. If these settings are not correctly configured, redundancy may silently fail, leaving the system exposed during an outage. Cable type consistency is essential in redundant paths. Both links should use the same category of Ethernet cable, or the same type of fiber. Mixing gigabit and 10 gigabit connections, or copper and fiber, can create mismatched speeds, latency variation, or even negotiation failures. Server Plus includes symmetry enforcement, ensuring that both redundant paths offer the same bandwidth and physical behavior for predictable failover. Redundant cable paths must be tested before the system goes live. This includes unplugging one cable while monitoring traffic, then repeating with the other. Both links should maintain connectivity and show failover within the expected time frame. Testing should include sustained load, since some faults only appear under traffic. Server Plus stresses pre-deployment validation because many redundant systems fail the first time they're needed if they are never tested under real conditions. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Clear and deliberate labeling is essential to managing redundant network cabling effectively. In a system where each server has multiple network connections, it's critical that every cable, port, and interface is labeled in a way that corresponds to the rack layout, logical diagram, and switch configuration. For example, labeling a cable simply as Ethernet 1 is not sufficient. Instead, it should be labeled with its role, such as, quote, primary uplink to core switch A, port 1 inch, and the server it connects to. This helps technicians quickly identify which cable is which during maintenance, upgrades, or emergency troubleshooting. In shared environments or large data centers, labeling also prevents accidental disconnection of redundant links during planned work. If both cables from a server appear identical and unlabeled, a technician might unplug both while intending to remove only one. Proper labeling not only accelerates diagnostics but also supports audit requirements, improves access control, and reduces miscommunication between teams. Server Plus includes cable identification as part of physical documentation and fault response planning. Failover behavior in redundant network configurations also impacts MAC address continuity. Some redundancy setups preserve the original MAC address when traffic fails over to the secondary link, ensuring upstream devices continue routing traffic without interruption. In other cases, particularly with certain teaming modes, the MAC address may change when switching interfaces. This can lead to delays in network convergence, as DHCP servers, access control lists, or security appliances may reject or delay traffic from the new address. Understanding how MAC addresses are handled during failover is essential for preventing connectivity loss during a network event. Redundant cabling applies equally to fiber optic networks. Fiber links offer high bandwidth and long-distance performance, but they're just as vulnerable to breakage, connector failure, or light loss. Dual fiber links can be established using SC or LC connectors, depending on the equipment in use. Often, two optical transceivers are installed in separate switch slots, with each fiber cable following a different physical path. Light levels and error rates must be monitored continuously to ensure link quality, and any failover behavior must be tested under realistic load to confirm that the network can recover quickly and without error. Redundant fiber infrastructure requires careful planning around connector cleanliness, bend radius, and port selection. Fiber cables are more fragile than copper and can be damaged easily by sharp bends, improper insertion, or unprotected routing. Just like Ethernet, redundant fiber runs must be separated physically and logically. If both links run through the same conduit or patch panel, they're still exposed to single-point failure risk. Server Plus includes fiber redundancy practices to ensure uptime in both copper and optical environments. Redundancy that is not correctly isolated can introduce serious network instability. For example, connecting two switches with multiple links without proper loop prevention measures creates a layer 2 loop. In Ethernet networks, this causes broadcast storms, where duplicated packets flood the switch fabric until all bandwidth is consumed. To prevent this, administrators must enable protocols like Spanning Tree Protocol, which automatically blocks one of the redundant paths and reactivates it only when the primary path fails. Server Plus includes loop awareness and control as part of network redundancy design. Documenting redundant paths is an ongoing responsibility. Technicians must maintain up-to-date diagrams that show not only which switch ports are connected, but how they relate to the logical network. Physical diagrams should display rack elevations, cable routing, port numbers, and color codes. Logical diagrams should show teaming modes, VLAN mappings, failover behavior, and switch roles. These diagrams serve as a reference during outages and are also used during upgrades or infrastructure audits. Without documentation, diagnosing a broken link during a crisis becomes guesswork. Redundant links must also be monitored in real time. Monitoring tools should track bandwidth utilization, packet error rates, and link status for both the primary and secondary paths. Alerts must be configured to detect when a link fails, even if traffic automatically switches to the backup. If the failure goes unnoticed, the system is running without protection until the issue is resolved. Server Plus emphasizes the role of monitoring in redundancy because visibility is the difference between a minor incident and a system-wide outage. In large-scale deployments, redundant cables often span multiple racks or rooms. For example, a backup cable may travel to a core switch in another aisle to protect against localized failure. These cross-rack connections must be planned carefully. They must not exceed maximum distance ratings for the cable type and must maintain signal quality. In fiber deployments, this may include inserting optical amplifiers or selecting low-loss connectors. Redundant cabling between racks must also maintain consistent latency and bandwidth to prevent routing asymmetry. Deployments spanning multiple facilities, such as disaster recovery sites, take these concepts even further. Redundant links may connect to backup switches in separate buildings or data centers. These links require encryption, traffic shaping, and possibly even network address translation to maintain functionality. While this is beyond the basic Server Plus scope, the exam does include awareness of redundancy principles that scale beyond the rack level and into the enterprise. In total, redundant network cabling is not just about adding a second cable. It is a carefully orchestrated system of paths, interfaces, protocols, labels, and tests. It protects the most critical function of any server, staying connected to the rest of the infrastructure. When redundancy is done right, failures happen invisibly. When it is done wrong or not done at all, recovery can take minutes, hours, or longer. Server Plus candidates must understand not only how to connect these paths, but how to test, document, and maintain them across the full life cycle of the infrastructure. In the next episode, we will shift focus to physical media. We will examine the structure, use cases, and performance characteristics of twisted pair versus fiber optic cabling. Understanding these materials is essential when designing infrastructure that balances cost, bandwidth, and deployment complexity. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.